All right, so we got to do the MVT for integrals, and you go, wait, mean value theorem, we've done that. We've done it for derivatives, however, and we have to do the MVT. There's one for integrals as well, so another one of your theorems. I'm sure you're so excited. And then the average value of a function. Now, the average value of a function is exactly what you think it is. If f of x, and you can find it, if f of x is integrable on the interval from a to b, then the average value of f is what? Well, it's basically like, think about, it's almost like if you're adding up all the change of the function and then you're finding the average y value. So it's almost like you're finding the change divided by the interval that you're on, and so it becomes 1 over b minus a times the integral from a to b of f of x dx. Now that's the way it's written in a lot of books. Obviously, I could write that with this integral. I mean, isn't this the same thing if I write it that way? And you know me, I'm a word person. So when I see the average value of a function, I think integral over interval. Now, if this is on the AP exam, friends, you can't just write this. You're going to have to actually write it out this way with the equation. But certainly integral divided by interval helps me remember what the formula is. So if it says find the average value of f of x on 1 to 4. Now this is not calculator, so I'd have to do it in my head. I would think, okay, that's integral. So I'm going to put the integral from 1 to 4. Now obviously I could just write f of x, but since I'm having to do it by hand, I'm going to go ahead and write it out so I know what I'm doing. I'm going to take the integral of this, and I have to divide by the interval 4 minus 1. Now we talked yesterday how you're going to evaluate that integral. You're going to take the antiderivative, so that would be x cubed minus x squared. It's not too bad. From 1 to 4. And obviously I'm going to divide by the 3. That's the interval part. So if I plug in 4, let me think about what that is. So if I plug in 4, that'd be 64 minus, if I plug in 4 minus 16, then minus parentheses, if I plug in 1, oh, that's 1 minus 1. Oh, that's nice. That ends up being 0 over 3. So what is that, 48 over 3? And remember, on free response, you wouldn't really have to reduce, but if this is on multiple choice, they would probably put the most simplified answer, which would be 16. So the average value of all those y values from 1 to 4 is 16. I do want to talk about this because this becomes a where a lot of people get a notation mistake, a linkage error. Notice what I have when I have equals, 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 equals. That's perfectly good notation, and I could write it that way, and I wrote it that way because I didn't have a lot of space. But we've talked about with these equal signs, notice that every single one of these things is equal. If you do that, then you're not going to have a linkage error. But the trouble is, what a lot of people do is they write it, and I'll do a little shorthand version, but they write this, they're like, okay, let me get this integral, and they show that, dot, 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 and they get down and they go, okay, that's going to be this, from 1 to 4, and then they show the work, and they get down to 48, and then they go, oh, sweet, divided by 3 equals 16. And they write it like that. Well, all of those things are not equal because this integral is not equal to 16. So you've got to make sure if you're putting equals, 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 they all have to be equal. Now, if you want to do it in steps and do the integral first, that's fine. Get down to the 48 and then go 48 divided by 3 kind of on the next line equals 16, and you're good to go. But You just want to be careful that you don't have a linkage error in your work. So average value, integral divided by interval. Now let's talk about the MVT for integrals. Now notice really the only condition is you have a continuous function from A to B. The conclusion is there must be a number C and AB such that, well, okay, we kind of knew that one was coming. So here's the MVT for integrals. And I want you to think of Goldilocks and the three bears, okay, or the Goldilocks and the three rectangles, if you will. So Goldilocks comes along and says, okay, I'm trying to find the actual area under the curve. And along AB, okay, I'm going to have this rectangle here. I'm going to pick a value of C somewhere between A and B that I think the actual area under the curve would be the same as this perfect rectangle. So here's the deal. The first time Goldilocks comes along and says, you know what, I'm going to pick a C value right here. And so my rectangle would be this one. Now, does it look like that the area of that rectangle is the same as the actual area under this curve? Well, of course not. This area of that rectangle is a bit too small. So then she said, all right, fine. I'm going to pick a value of C way over here so that my area, my rectangle that I'm finding, is this one. And she found the area of this guy and compared it to the actual area. And of course, this one, the area was a wee bit too big. And then she got wise and she picked a value of C somewhere in there that the actual area of this guy, the area of that rectangle, was just right. Bedtime story for your kids one day. So what does the MVT say? It says that there is some value of C between A and B, and technically it could be an endpoint depending on the curve, it usually isn't, that the actual area is equal to the area of the perfect rectangle. Now, let's look at this rectangle, and I bet you can figure out the formula. Y'all, if I ask you for the area of that rectangle, what would you say? The area of a rectangle is base times height. Well, what is the base? Well, the base is this amount right there. So wouldn't that be B minus A? Now, what is the height? The height of the rectangle is whatever the Y value at C is. So F of C. And that's your formula, correct? Now, yes, you can memorize it that way. Again, I'm wordy. Let's look for a second. Let's rearrange this formula. If I were to solve for F of C, can you look at this and go, if I were to get this formula and solve for F of C, I would get, well, the integral from A to B of F of X dx over B minus A. Now, does that sound familiar? Well, golly gee whiz, that's what we just talked about. This is the average value. So for the MVT for integrals, when most people, or when I figure out the formula and I forget it, I go, you know what? F of C, this height, this Y value ends up being the average value of the function. And that's how I remember the formula for the MVT. I'm like, F of C is average value. And then I can go from there. So let's look at a formula, or let's look at a problem where we can use that. So let's go to the next example. It says find the value of C guaranteed by the MVT for integrals for that function. Now obviously we see that that is a continuous function because we know that now it says that it's guaranteed, so you wouldn't necessarily have to write this, but I want to be clear because a lot of times it asks you when does the MVT apply. Notice that f of x is continuous from 0 to 2. It's a polynomial, so it is. So it says find the value of C that's guaranteed by the MVT. In my brain, I go f of C is equal to average value, right? So now what's the average value? Remember that the average value is the integral over the interval. Now again, you can either put 1/2, you can put over 2 minus 0, whichever you want. So this is kind of what we did before. So let's figure this average value. That would be 1/4 x to the 4th plus x. I'm going to evaluate that from 0 to 2. And then sometimes I can kind of combine. I'm going to multiply 1/2 because of this over 2. So what do I have? I have 1/2. If I plug in 2 to the 4th is 16. 16 divided by 4 is, did I do that right? 2 to the 4th is 16. 16 divided by 4 is 4 plus 2. And if I plug in 0, well, that's just going to be minus 0. So what I really have there is, what is that? 6 divided by 2, and that's 3. Okay, so that's the average value. Now f of C, remember that means your f of. This is f of. Now I don't usually put the C in there because once again, I like to set my equation x cubed plus 1 equal to that value that I got, and then I end up solving. So I have x cubed is equal to 2, so x is equal to the cube root of 2. Now I then write my C value because remember in solving, and I get the cube root of 2. In solving over here, when depending on your function, you might get several values for x, but remember your C value, as we've done so many times, has to be within that interval. So once I get the average value, I set my equation equal to the average value. So I got my equation equal to the average value. I solved and I got my C's. So that is how I do that. Now that was with the non-calculator, and on your homework is actually broken up into a non-calculator and a calculator section. So again, follow it. Your test is going to be that way, so follow those things. But in the next example, it says I can use a calculator. So if we think about using a calculator, let's use it to the best of our ability here. Now, before I start typing, I think about what I need to do. Well, it says find the value of C guaranteed by the MVT for integrals for that function. So I'm really doing, the question is the same as the last question, but I'm just going to use the calculator to be smart about it. Okay, I'm going to get the average value with the calculator. The average value is going to be the integral from 1 to 5. Now, if I'm using a calculator, frankly, I'm not going to write the equation. I would just write that over 5 minus 1, correct? I am going to take that value and I'm going to use my calculator to get that. then what am I going to do? Well, I'm going to see when this function, now I could put f of x, yes. When does f of x equal whatever value I get right there? And I'm gonna solve that. So let's get my calculator out so you can follow me there. So I'm gonna, once again, I like putting my equation into y1 because I only like to type it in once. So x minus 3 square root of x. So x minus 3 square root of x. So I'm going to go to my home screen. Again, I could technically do this on the graphing screen, but I like doing it here. I'm going to hit Math 9. I'm going to get the integral from 1 to 5 of that function. Now be careful. What did I forget? And I purposely did it that way. A lot of people do that and they go, oh, when does f of x equals negative 8 point, what did I forget to type in? I forgot to type in the divided by 4, right? So I've got to make sure that I remember to put that divided by 4 in there. So that's my average value. Now I can write that down and I can write it to 2 to 3 decimal places. But remember, I don't want to round. I want to see where f of x, and I'm going to go ahead and make sure that you understand. This equation is pretty simple. Where does this equal this? Okay, on 1 to 5. That's basically, not that you have to write that down, but with the calculator, you want to be smart about it. So here's this number. Remember, I like to store. So I'm going to store that into A so that I don't use the rounded value. So let's go back to y equals. Friends, anytime you have something like this, where you have a function and what it needs to equal, you do y1 and y2. So I already have y1 in there. So again, that's why I like to put it in there. And in y2, I'm going to hit alpha A because that's this number right here, the whole thing. Now, before I hit graph, I'm going to be smart about setting my window. I don't care where it's hitting outside 1 to 5. The only C values I'm going to write are 1 to 5. So why not put your X-min and your X-max from 1 to 5? That's all that you got to look. Now I'm looking, my Y2 is -2, so I could make this a little tighter. I'm not saying -10 to 10 wouldn't work, but I just like to emphasize the piece of the graph that I really care about. So there's Y1, there's Y2, and I could say, well, gosh, it looks like it's hitting in 2 different places. I can hit second calc value. Doesn't matter the order that you find them. I can go over here. Looks like there's an intersection there. So I could write down again. I could go to I will go to 3 decimal places. So 1.210. Obviously, you don't have to write the 0. If you put 21, I'd give you credit. And then do second calc 5 and go over here. And hit enter 3 times. And I got 3.6109, I guess. Yep. And 3.609. So I have 2 values of C. Notice they're both between 1 to 5. And these guys would be my answer. So remember with that solving, again, you can do y1, y2. Let me just say this. I don't want to confuse you, but I want to give you options. Some people move everything to one side, like they would have this, and they would pop that A to the other side, and they set it equal to 0 so that they're looking at the x-axis only. and instead of having to change your y's, you always do it with the x-axis. I could certainly do it that way. If you notice, think about subtracting a from both sides. So if I go minus a, and then I put in 0 here, I can see it a little better where I'm crossing that x-axis, and I could do second calc intersect at both of those places and get the same thing. So you can choose whichever way you like better in getting that value. So do your homework, some of it with a calculator, some of it without, and do MVT, an average value. Peace out. Peace out.